Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at shared pointers in C++11. So following on from the tutorial on unique pointers, shared pointers are really similar. They just add a little twist, which is that they don't delete the memory associated with your objects until all the pointers that point at that object have gone out of scope. So you can't use shared pointers at the moment to point at arrays. That might change in C++ 2017, but here in 2015 we can only use them to point to individual objects. So let's take a look at this. One way to create a shared pointer is the same as the way we created our unique pointer in the last tutorial. So we can say shared underscore PTR, specify the type, which in this case I'm going to use my test class. Whoops, try and get these brackets right on this new keyboard I've got here. So that should be that. Okay, so let's give this a name, like I'll just call it test1, or maybe we should call it ptest1 equals, and I can set that equal just to well, actually not equals. I should use the constructor of the shared pointer here and put in new test. So we're not going to be using arrays because we can't do that, but it works fine like this. So let's also put in some text here again, just so that we can see a bit more the flow of what's happening and when things are happening. Let's just put finished and need the endler. Okay, so if I run this now, let's build it and run it. So we see we've created a test object, and we've output finished, and we hit the end of the scope here, and we've output destroyed. Now the kind of best way to create a shared pointer is to use the make shared macro. So the way that works is that we set that equal to make underscore shared. And we don't have to use new ourselves. This is just like a template function. And these brackets are really driving me crazy. We just put the type of the class in there. I just can't remember where everything is yet on this keyboard. Okay, so this is going to create our object now. And apparently, according to the documentation, this is more efficient than doing it using new yourself. So if you forget, you can just create your object the same way that we did with unique pointers, but this is a slightly better way. Well, that didn't work too well because I forgot the brackets here. We need round brackets. This is not something I've ever used myself in actual code, to be honest with you, shared pointers. But it's something that I wanted to cover because it's a new C++11 feature and it could be useful in some situations. Okay, so this works now. We just got make shared with the template type there, and of course we need round brackets because we're calling some sort of function or something there. It could be a variety of things, possibly a function, I don't know. Okay, so but what we can do now that's different is we can create another shared pointer, shared PTR, and we need it to have it the same type, of course, because we're going to point it. Let's call it ptest2, and let's point it at ptest1. So now we're not going to get the memory being destroyed until both of these local variables here have gone out of scope, and they don't have to be local variables. You can pass these pointers around to functions or whatever, just as you might expect. But this is basically the whole type of the thing that you'd need if it was a like function parameter. So we can't see any difference here, and to actually see any difference, I'm going to have to create a restricted scope. What I'll do is I'll move this up to the top here, I think, and we'll initialize this for a start to null pointer. So if you're gonna declare a shared pointer, but you don't want it to point anywhere initially, you should always initialize it with null pointer like this, null PTR, which is the C++11 equivalent of the old null macro, because that just makes it clearer what's happening. So now let's put this in its own scope. Here's some more fun with the brackets. Let's stick another bracket there and format that. So this is going to go out of scope here. So we'd expect to see the destroyed now coming out before we see finished. If I run that now, then we get destroyed and then finished. What we can do is we can point ptest2 at ptest1. Now ptest2 doesn't go out of scope till we hit that lower bracket, so we're going to see the destroyed happening now after finished again. Let's just run this and see that that does happen. So there we go. So now the difference is that we don't get the memory associated with this object, which this make shared creates for us. We don't get that being deallocated, being deleted, until all the pointers, including this one here, that point to that object have gone out of scope, which is quite good. If you did just need another pointer at the same scope, you could just use auto, of course. You could say auto p test3 equals p test1 or p test2. It doesn't matter. But here, because I needed to declare the variable without actually initializing it at that point, auto wouldn't have worked in this case. Okay, so apart from that, it's exactly the same as a normal pointer, and you can use the square brackets on it or dereference it or do whatever you like, basically. So you can replace, in general, you can replace your pointers with unique pointers most of the time. And if you've got some situation where you want that memory to hang around until all the variables have gone out of scope to point to it, then you can switch to using shared pointer, and that's going to hopefully cover most, if not all, cases that you will encounter. And there is another type of pointer which I can't actually remember at the moment that you can use if you've got a circular reference, but it's better to avoid circular references, full stop. If you've got an object that has a field that refers to a field in another object, and that object refers back to the first one, something crazy like that. But it's better just to, in my view, just to avoid that situation, really. Try to restructure your code so you don't get the circular reference. Okay, so that's it for this tutorial. Until next time, happy coding.